all, welcome to Corpnce. I am Rono Savio and in this video we'll be discussing on the topic containers in Python. So before we understand what is containers, let's see the fundamental data types. How you store these fundamental data types in Python. You have integer, float, boolean, string, those are all fundamental data types of Python. And you store them in a single variable, right? But now let's say you have a single variable and you want to store multiple data types of this. Like you want to store a string, an integer, a float, a boolean all together in one particular variable itself. Now the concept comes about containers. So containers are like a box. You just stuff all these values inside and you just close the box. And depending on how you stuff those values inside a box, the containers are categorized into 4 types. They are nothing but tuples, list, set and dictionaries. 4 containers of Python. And in this video we'll be discussing on list and tuples, and we'll start with tuples. So tuple is known as the default container of Python. The reason why it's a default container is, see here, I'm in my VS Code, and if at all I declare a variable, okay, and I declare a single value, let's say I'm declaring 1, and this is nothing but an integer. If I print the type of it, you can see it is pointing towards class integer. Now let's say I want to make it a tuple. I don't have to declare anything. I just pass in multiple data types, 34, 23, whatever, okay. And now if I run this, you can see now the type of this particular variable a is tuple. What happened? You didn't declare anything else. You just gave multiple values to it with a single variable. So Python automatically is like, okay, the user is giving me multiple data types to a single variable, or maybe I don't have any other containers declared there. So this means that this should be a tuple. That is how it works. That is the reason why tuple is known as the default container of Python. Now, tuple can store heterogeneous mixtures of data. What do I mean by heterogeneous? So here if I try to store multiple fundamental data types, not only integers, I can store even float, boolean, let's say 45.7, doesn't matter. Or let's say I want to store a string, I'll say hello there, hello is fine. And if I run this, it runs without any error, because tuple doesn't care whatever data type you pass inside it. You can literally pass a tuple inside a tuple. So that is called as nested tuple. We'll see that later. And tuple is indicated with parenthesis. If at all you declare it with parenthesis, it is a tuple itself. If at all you don't, it's a default container, it doesn't care. You just pass in multiple data types and it will be like, okay, fine, I'm a tuple. So yeah, it works pretty good. Now you can see indexing in tuple. So what do I mean by indexing? Here, let's say all these values that you have declared, you want to access them. It's a waste if you just store all those things and you can't access them, right? So what do you do to access them? You say a of 0 and I'm getting 1. How is that working now? In indexing, let's say this container tuple, and there's one more called list, we'll see that later. But in tuple, if you say a of 0, you are pointing towards the first index position, and index positions start always from 0 for these containers, and it goes all the way from left to right, all the way. It starts from 0 and keeps going. So if I say a of 1, you can see I'm getting 34, the second value. Then if I want the, let's say, 4th value, the boolean value true, then you see it should be 0, 1, 2, 3. I have to go a of 3 then. You can see I can access the boolean value. That is how indexing works. And yeah, tuple is known as immutable. Now you are able to access values, and I'm saying only accessing values is there. You cannot do anything else. You can just see what is there. It is like the transparent box where you can only see the values inside it. And if at all I try to change the value, so like a of 3 is nothing but true, I'll just say I want to make it false, 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 okay. And if I run this, you can see the error here that is popped in my screen. It says tuple object does not support item assignment. What is happening here? Now we'll see one more container called list, which is very similar to tuple but quite different too. List is also a container very similar to tuple. And list, unlike tuples where you literally have to declare a tuple with parenthesis, so, or you don't have to declare it with a parenthesis, it's a default container. But here if you want to declare a list, you have to declare it with square brackets, okay. And just like tuple, List can also hold heterogeneous mixtures of data. So it can be hello, spelling is wrong, but it's fine, and true, a boolean value, whatever you want, you can store it in a list too. It does support heterogeneous mixtures of data. And if at all you want to access the value, you can access it the same way how you had it in tuples, right? You can access it with b of 0. So the first value of the list will be accessed, which is nothing but 3. I will wait for this kernel. Yeah, got 3. And if at all I want to access the second value, I have to go with 1, that is nothing but 4. If I want to access the value 5, which is the third value, I have to go with 2. Okay, simple as that. Now it's like very similar to tuple. The only difference you saw is that square bracket thing. So what is very different from tuple is that list supports item assignment. So now if at all I want to change the value of b of 0, so b of 0 is nothing but 3. I want to change the value of 3 to, let's say, 55 or something, and you see that the value has been changed. So list supports mutability. The list containers are mutable containers, unlike tuples where the values once stored you cannot like change it at all. So that is the main difference between a list and a tuple. Now here these lists and tuples are known as ordered containers. They come under ordered data types. The reason is you are able to store this value in a particular order, right? That is the reason why they are called as ordered containers. So if at all especially in tuple, if you store the values once, you are not changing the sequence of it. It is like there itself, fixed. But when it comes to list, it's like, it can change. You can change the values. That is one of the disadvantages of list. Also an advantage, even though it is flexible, it makes list slower. We'll talk about that. But yeah, you understand the concept why it's ordered container, because you have a particular sequence, index positions for it. It is fixed index positions. Now the actual question here is, how does this Python actually tell this tuple or a list to be mutable or immutable? So tuple is said to be immutable. You cannot change the values in a tuple. And how does Python do that? And list is mutable. Whatever values you given, you can literally manipulate or change them. But you assume that, okay, list is said to be mutable, you can change the values, and tuples are said to be immutable, you can change the values. You cannot change the values, I mean. And how does that work? Like, you have to question yourself that, right? So here there is something called as dunder methods. If you haven't heard of dunder methods, they are defined as the core behavior of Python. So what exactly do I mean by that? A equals, I'll go with the tuple. I'm declaring a tuple here, and I've given some random default values. By default, it will take it as a tuple container. If I run this and if I print the type of A, you can see that it's a tuple. It is pointing towards a tuple class. Now, what do I mean by exactly this A is a tuple class? It is belonging to a tuple. When I check what is inside a tuple class, so what I have to do for that is print the dir, the directory of the tuple class. If I run this, there are many double underscore methods which are nothing but your dunder methods. So you can see all these names have double underscores. They are starting with double underscores and ending with double underscores. These are your dunder methods, and these dunder methods belong to the tuple class. And what do these dunder methods do? So it literally tells tuple to behave like a tuple. So if a tuple needs to be immutable, there is something called as, actually there's something missing actually, which makes tuple immutable, unlike list. And before that, why you are able to access values in a tuple is because of getItem dunder method. You have double underscore getItem, which is literally making you, like, helping you to access the values in a tuple. So whenever you are saying A of 0, you are getting this value 1 here. That is nothing but this getItem dunder method doing its job. It is helping you, giving you the permission or the behavior for the tuple to access values, to let the user access its values. And now, if at all the getItem is the one that is helping the tuple to access values, then maybe even in the dunder methods of a list, it should be present, right? Because even list, you can access the values. So if I go to the, if I create a list, let's say, if I say this is a list now for some random values, and if I say print, type of A or type of B, this should be a list. It is pointing towards a list. And if I literally say print dir of B and run it, you can see the dunder methods of a list. This dunder methods belong to the list class. And here also you have get item dunder method. The reason for you to access values in a list container. Now the golden question or the statement, you can actually change the values in a list because of a dunder method that is present in list, not in tuples, and that dunder method is called as set item. If I scroll here, you can see there is a dunder method starting with double underscore, set item, and ending with double underscore. This dunder method is a reason why you are able to change the values in a list. But check it out in tuples. If you search for that dunder method, it is not present. After set attribute, there is something called a size of and so on. So this is the main reason why your tuple does not allow you to assign an item or change the values inside the container of a tuple. And all these dunder methods here do one or the other task. Whatever you are able to perform with list is very flexible. You have many built-in functions of list. Unlike tuple, due to its fixed nature, you cannot do much manipulation task with tuple. And tuple is considered very faster compared to list because of the varying data types in list. And yeah, these dunder methods are the ones that are helping list to behave like a list. And for tuple also, the dunder methods specifically assigned to tuple is making it behave like a tuple. So I believe you understand how dunder methods are the core behavior of Python, not only for a tuple or a list. Every other data types or whatever you create in Python already has dunder methods working behind it, or creating a guideline that you data type or something customized by yourself should behave in a certain way because of the dunder method present behind it. That is how dunder methods work. So in order to understand how this get item set items work, I'll give you a clear example with a class to see how this get item is making it accessing values, and set item is like changing values. Here I'll create a class and I'll say my personal container. Okay. In this class that I've created, I have to give a boilerplate code. So the boilerplate is nothing but init and self. Here self dot data equals data. I mean, let's pass in some values 10, 20, 30. So I've passed in some random values in my data. So in this class, I have a list with some data. This list is going to follow whatever I'm going to tell it, because now I have to create an object of my class. So I'll say my container equals my personal. Yeah, this is how we create an object of a class. This should be AI. Okay. Now you use this. Now I'm trying to access the first value of the data that I've passed into this class, my personal container. In my container, I have 10, 20, 30, and I'm trying to access the first value using the expression. And I'm getting an error here. The error says my personal container object is not subscriptable. So here I have to teach my class, container class, that how to access value. And you know that to access a value, you use get item, the dunder method get item. So I'll create a dunder method here, get item, and then I have to pass in the attributes. First one will be the self attribute. So the self attribute, it should be inside. Self attribute actually takes the data from your boilerplate. So it is passing down those to your methods. And here the next one will be the index. So which index position you are trying to access. So two attributes. From the particular self.data, which index position you are trying to access. That is what get item is going to do. So return self.data of index, right? whatever index value you are given. So you have given 0, let's see. And in order to make it more clear, whenever you are trying to access, like say my container of 0, you are actually accessing the get item Danda method. So here I'll say get item Danda method is called. So you can see that it will print a statement that get item Danda method is called. So if I run this, now you see get item Danda method is called and the value at the index position 0 is nothing but 10. You can see in the data that I passed in my container, the first value index position 0 has the value 10. Now fine, you are able to access the value using the get item. Now if I try to change the value, you can see my personal container doesn't allow that. It doesn't support item assignment, it says. It is very similar to how tuple responds, right? Because even tuple has this set item missing. And in my container, I want to actually add the set item, let's say, because I want to actually change the values in my data. So what I'll do, I'll create my set item, and in the set item, you have 3 parameters. One will be self, attributes, and other one will be your index. Then the one more extra one is nothing but the actual value that you are replacing. So here you can print your set item Danda method is called, and then you can return, or don't need to return also. You just can say self dot data of index that you're passing in equals val. It's clear, right? You are changing the value with the index position that you're passing in, with the actual value that you want to change it with. So print, you can print the self dot data, or you can return it also, it's no issues. Now if I run this, you can see, okay, it's already 10, so I'll keep it changed, literally a string here. Now if I run it, you can see set item Danda method is called and the first value has been changed from 10 to the string value changed, and rest all is same. So this is how you can actually use get item set item, and this is exactly how your other container tuple and list is also using these Danda methods to actually function. Rest all the Danda methods are the same way how it is functioning. This is just an example of set item and get item. If you want to create a lot more flexibility for your code, you can actually involve a lot more Danda methods, like you want to compare with two values or something, two containers or something, then you can have Danda methods specially for that too. Let's check out indexing and slicing in these containers of tuple and list, because both these containers have the same indexing format or slicing format. So whenever you are trying to access the value, the format is very similar. So here I'll take an example of a list, and I'll show you something that most of the people miss as a beginner. Whenever you are trying to access value, you go and learn the simple way. A of 0 is 1 or A of 1 is 2. You are able to access the values like this, right? This is totally fine, but what if you have a nested list? You know that these containers, tuple or a list, can hold heterogeneous mixtures of data, and that also includes a container itself, like a nested list or a nested tuple. So here you can have 6, 4, 5, so on. So you literally have a list inside a list here. And now what do I do to access this particular container? So you can see that the whole container, that list present inside a list A, you have declared a variable A, that is your container, and in that container you have one more container which is having values 6, 4 and 5. Now I want to access that small container which is present inside your actual container A. So what I'll do, I have to find the index position of it. So that container is present at index position 0, 1, 2, 3. It is at index position 3. I'll run this. You can see I'm getting 6, 4, 5. And now if at all I want to access the values inside that container, then I have to go with 3 of, let's say, 0. I'm getting 6, the first index position of that particular value in that nested container, nested list. So this is how we can access nested values. Same goes with tuple also. So here I will declare the same thing, and you can see that if I declare it here, like this, and let's keep it as a tuple. Okay, so tuple is nothing but declared in parenthesis. I'll make all this parenthesis now, and here same format. If I say b of 3, I get 605 and 0. It doesn't matter because whatever or either slicing or indexing format you have in list is same for tuple also. And let's keep tuple as an example. So whatever I'm performing on this list is going to be same for tuple 2. Okay, and I'm keeping list as an example to represent tuple also. And I will start with the basic syntax. So here you have start, stop and step while you are indexing or slicing in a container, especially list and tuple. And here start is known as inclusive and stop is called exclusive and step is set to be 1 by default. So what do you mean by start is inclusive, stop is exclusive? So here when I say a of 0, okay, literally you are just accessing the first value, nothing new. Now if at all I want to give a range, okay, so now 0 is at the starting point. I gave a double colon, you can notice that. So double colon shows that next what you're going to do is put a stop sign. So you start from 0, you want to go up to, let's say 3. So you have 1, 2, 3. I want to print those first 3 values. So I'll say I want to go up to 2, 0, 1, 2, right? Because initially that first index position starts from 0. And if I run this, you can see I'm getting only 1 and 2. You notice that even though the index position of 2, which is the stop, is actually the value 3, I'm not going up to 3, I'm going only up to the value 2. The reason is start is inclusive. When I say inclusive, it includes that whatever starting point you're giving, whereas stop is known as exclusive. So when I say exclusive, when you stop at a particular point, it is not exactly stopping to the actual value that you're giving, which I've given here is 2. It is not going to the index position 2, it is going only up to index position 1. If at all I give index position, the stop index position up to 3, only then it will go up to 2. So if at all I give up to 3, you can see only then 3 is included. So if at all I want to, let's keep it more simple. I think numbers might confuse you, so I'll keep it some fruit names, apple, mango and banana, something. Okay, let number also be there. So now you can see if I want to go up to, let's say banana, you have to go up to 3. So 0, 1, 2. You can see the index position. So the third index position was actually 45, which was not included in this because stop is exclusive. And if I want to give step, step is a little more different. If at all I told you step is by default 1, and if I run this, it doesn't make any change because you actually didn't do anything, you just added the default value 1 itself again. If I give 2, you can notice that mango has been jumped. So step actually defines that how you iterate through those values. So you climb the stairs, right? You go 1 step at a time. Some people jump 2 steps in between. That is what you did here. You gave the step count as 2 and 1 step was jumped in between. That is how it is going. So if at all I give empty colon, here when I give empty colon, by default the indexing takes all the values. Start and stop is not given, so it by default includes all the values. And I'll give one more colon. So you can see that starting colon is for start, then in between you have stop, then here comes step where I'm giving 2. You can see apple, mango jumped, then came banana, 45 jumped. That is how it is working. So this is how step works in indexing and slicing of containers. And this is just basic ones. Then if I give -1, you can see that whenever step is -1, you are getting reverse of this particular container. And notice that whenever you have step as 1 and you give 0 and let's say 3, up to 3, this works pretty fine. Apple, mango, banana, it goes up to index position 2, which is banana. Okay, and what I'll do is I'll give this index position as -1. Now you might be assuming that, okay, I have to taken a range. Now when I give -1, it should give a reverse of apple, mango, banana. It should be banana, mango, apple, right? But when I run this, you see I'm getting an empty list. What is happening here? So whenever the step is -1, the start and stop will interchange. So now 0 is at the stop position and 3 is at the start position. And start should always be smaller than stop, because whenever you're starting, it should be the left hand side, it should be at the leftmost. The start should always start from the leftmost and stop should go at the right, so it should go in this sequence. But what happened here, your stop is at 0, so 0 is here and 3 is here. 0, 1, 2, 3, and 0 is at the stop position. Stop has come to the left hand side and start has went to the right hand side, which is causing the issue that the range is not matching, because the -1 has caused this issue. So what you do, you make sure that 3 is at stop and 0 is at the start. So now it is in the perfect order. Now you run it, you can see it has reversed it. This is how index positions work. I mean slicing works in containers. So if at all this one is confusing, you don't have to focus much on that, because for beginners it might feel a little complex, but this is something important if you are working with slicing and indexing. Something important to know if at all you go further, and maybe you come across a bug where you are using -1 and you are getting an empty list or a tuple. This might be the cause. This video is sponsored by Corpnce. Corpnce is a Bangalore-based leader in training and consulting for data science, machine learning, artificial intelligence, and also deep learning. At Corpnce, we strongly believe that real expertise comes from hands-on experience and not just theoretical learning. That's why our programs are project-driven and taught by industry experts who work with real-life applications every single day. This ensures our learners get hands-on skills that is aligned with the current industry. Over the years, we have helped students, working professionals, career switchers in building strong foundation, stand out in interviews, and advance confidently in tech fields. If you are looking for structured, industry-focused learning which will allow you to get real opportunities, then let Corpnce guide you. Alright, let's get back to our topic, list and tuples. Here's one more important thing that these beginners actually misunderstand. Here, let's declare a tuple, okay? This is a tuple here that I'm declaring. And in this tuple, I have a list. As I told, just like a list can hold tuple, even a tuple can hold list. So a list inside a tuple, okay? Now the question here is, do you think that the values inside the list can be changed, which is inside a tuple, a immutable tuple? So if I try to, print, or it's anyway a of 2, yeah, I'm able to access the list, fine. Now if at all I try to say 0 equals 10, it worked pretty fine. Even though the particular list is inside a tuple container, you can see that the value inside that tuple, which is nothing but the list, actually changed. Now the question will be like, okay, you told that it is immutable and it still changed. How is that possible? See, actually, if you notice, tuple only cares about the data types and the value it is having. So here 1 is integer, 2 is an integer, and this particular container here, next one, the third element in this particular tuple is a list data type, and tuple only checks if that list data type has been changed. It doesn't care whatever is inside the container of that particular list. As long as you keep it as a list container inside a tuple, it is totally fine to change whatever inside that list. So this is how it works, and same goes with tuple. So if at all you try to create a list and you have a tuple here, so hi, and you have 0 something like this, okay? Now you try to change the value of a tuple. So here 0, or let's say it's 2 actually, you're able to access. Now you try to change the value of a tuple, you try to keep it 0 equals 0. See, even list is like similar to tuple, but you can see how it always respects their boundaries. It doesn't cross the limits. It makes sure that tuple belongs to a particular data in that container, but whatever the tuple has to do inside the container is meant to tuple itself. Whatever values you hold or whatever rules you want to keep, you keep it. I won't bother you. That is what list is saying for tuple. Same goes here also. Yeah, the tuple is like the list can be in, like I can hold a list, but whatever the list is going to do, I won't mind as long as the list container itself is not changing. So what if you try to change the whole container itself? See, that will throw an error. So now a of 2 is nothing but your list, right? A of 2 is nothing but your list. Now you try to change that itself. You say I want to change it into what you say, change it. I'll keep a string called as change it, okay, and I'll run it. It won't work. Tuple object does not support item assignment. Now you get the point, right? And also one more thing, if at all you try to create an empty tuple, you can literally do this one. You can give the built-in function tuple, and this is an empty tuple, empty parenthesis, nothing is inside the parenthesis. Or if you want to create a list, you can just go with list. This also works. And list can also have square brackets. You can declare it like this, and tuple can also be declared like this. Okay. Now this also is an important thing that many of the beginners mistake, and this causes a lot of bugs in the code while you're coding also. So if at all you try to create a single value as a tuple, most of them, let's say I'm giving you a task to make a tuple container with a single value. They do this, okay. Now you will think that, yeah, this is a list, I mean this is a tuple, and if you see, you're getting it as class integer. This hasn't been converted to a tuple. Now what is wrong with this? You're given the parenthesis but it's not working. What about list? If I try to make it into a list, this is fine. For list doesn't mind, it is like okay. But only for tuple, it doesn't, work with that only parenthesis. So what you have to do, give a comma to it. Whenever you have just a single value that you want to assign into a container, a tuple container, you give that comma. That comma is the very definition for tuples that defines why it becomes a tuple. So now you can see, so now it has converted to a tuple. Even though you don't have this parenthesis, just with a comma, it is still a tuple. This is what many of the people make mistakes in. So make sure you don't forget this one. This will save you a lot of time while you are decoding. Let's talk about the built-in methods that you have for this container, list and tuple. We'll start with tuple because tuple is not that flexible and it only has two built-in methods. You have, before that I'll create a list, tuple. You see a dot, I'll show you how count works. So here count, you give 2 and let's increase the number of 2. If I run this, I'm getting the value as 5. This count method is literally giving how many times a particular value is repeated in a container. So yeah, in tuple containers, and you're getting 5 because the value 2 has been repeated 5 times. That is simple as that. Then one more thing is like dot index. In index you have 3 arguments that you can pass in. One is the value, then you have the range, start and stop, and it says that in the docstring of this particular method, it returns the first index of the value and it raises value error if the value is not present. So let's try. First I'll give a value 2 which is present at index position 1. Fine, it is working pretty fine. It is giving me the index position of it. Now I'll give something called as 200 which is not there. Run it, yeah, obviously value error. That's what I expected from it. That's what the docstring also indicated us. It says raises value error if the value is not present. Now what would I do? Yeah, I can actually say this too. If you notice this, the first occurrence is only observed here. You can see at the rightmost end you have 2 repeated, but it is not actually finding it, or it is not returning anything, any index position for that. So how do I reach that 2 then? Then what I'll do is, here as I said, I can pass in 3 arguments. But first one you're passing it as a value. Then what I'll do, I'll just give a range. Range I can start from anywhere I want, my desire, my wish. I'm the user, right? So I'll say 0, 1, 2, 3, 4. From the index position 4, you have the second 2 repeated. So I'll say from index position 3 you start and go until 4, 5, 6, 7. Okay, go until 7. But even though I go until 7, it's of no use, because whenever this particular method finds the first occurrences, it just stops there. It's like, fine, I found it, that's all, that's my task. So yeah, this is overall how dot index method works in tuple. Now tuple methods are done. It's like just 2 of them. We'll go to list, because list is more flexible compared to tuple. You will see many built-in methods that you can use on list. So here I'll convert this itself to a list. Yeah, just simple as that. You just give 2 square brackets and it's done. So what I'll do here is a dot, yeah, you can see that list already has 11 built-in methods that you can use. If I scroll further, that's nothing but its dunder methods, the double underscore I told you before, right? Now I'll start with the first built-in method for list, and that will be sort. Sort has, yeah, two parameters, I mean 2 arguments. One is the key and other one is reverse. Before we check it out, sort actually sorts the values. It's as simple as that. And now you must be wondering why it's not returning anything, because if you see the doc string, it returns none, and the reverse flag, okay, reverse flag we'll talk about it later. If you see the doc string, it has some definition of it, you can read it down. Sorts the list in ascending order and returns none. Okay, so what is actually happening here is a dot sort is actually sorting the values, but in order to see the result, you have to go to the original container of yours, which is nothing but a. If you print a, you can see it is not returning anything, it returns none, because it just changes and it's like an introvert, you can tell it like that. So you can see it is sorted. Now you have 2 arguments, right? One is the key and other one is reverse. We'll see key, but before we'll see reverse. Reverse is more simple. So reverse takes boolean value, and in boolean value, if you give true, now you see it sorts in the descending order. Pretty good, right? Let's see what key does. Key actually is like what, you can say key equals, and this actually takes a function as an argument, some function. You have not declared this function, but anyhow you have to declare a function in order for the key to work. So this key actually takes function as an argument, and this function is very important because the sorting order depends on it now. Because whenever you are sorting this particular container, if you are giving key as argument with a function to it, whatever that function gives the order, that order is maintained for the sorting too. So I'll keep this very small for your understanding. So I'll say 1, 3, 5. Okay, and I'll say def some function, and this will have an argument x. So all the values will be taken one by one from the container in this function, and I'll say return modulus, so x modulus 3. Good, right? And what I'll do is I'll run this 315. This doesn't look like sorted at all, right? I'm like, if I was you, a new coder in Python, and I look at this, I'll be very confused. I'll show you what exactly is happening. So if I print the modulus operation for each of these values in the container, which the function is doing for us, so I'll say 1 modulus 3, then I'll say print what was that, 3 modulus 5, then you have print, last one was 3 modulus 3 itself. Now if I run this, you can see 130. How? I mean, obviously it's the modulus operator doing it and not how, but now you arrange this particular values, this 1 3, okay, 3, okay, this should be 5, okay, my bad. Okay, 1 3 2, not an issue. So now you arrange this in a ascending order, 1 2 3, and instead of 1 2 3 these values, you replace them with your actual values that you did your modulus operation with. That 135, if you arrange them accordingly, you will get 315 depending on this 1 2 3. So 1 is nothing but your what do you say, 1, I mean, yeah, exactly 1. Oh wait, I made a mistake here. Okay, cut this part, I'll speak again. Okay, right. Here, if you check how this modulus operation is actually giving the values for each of these values in the container, so I'll say print 1 modulus 3, okay, then I'll say print 3 modulus 3, then I'll say print 5 modulus 3, and if I run this 102, you are getting 102 from the modulus operation. I have done nothing but just copied the function what it is doing. I have just printed it one by one. Okay. Now here, if you arrange this values 0 1 2, you can see 0 belongs to 3 and 1 belongs to 1 and 2 belongs to 5. So arrange them in ascending order and you will get 3 1 5. This order is followed because of that function what you actually declared. So now you see how key is very important. If at all you have an order in your mind, like your container should be sorted in this particular order, this is how you can use the key parameter or argument. Good, right? Now this, I believe, sort is cleared. Let's check out the other functions. Let's see, I'll keep this particular list itself and I'll say a dot. Next one what we have is called append. Append is very important because this is the one that helps you to add values at the end of the list. So if at all I want to add add what else, yeah, 10 is good, so I'll say a, okay, 1 3 5 10. So 10 is added at the right end of the list. Pretty good, right? Now let's say I want to add multiple values. One value is totally fine, but let's say I want to add 3 10s, okay, not just one. Now if I run this, oops, it says type error, you cannot do this. Exactly what it says is that list dot append takes exactly one argument, but 3 were given. You can see that bracket 3 were given. You notice that you give 3 10s. This is what happened. This append actually takes only single argument. It doesn't take 3 arguments. Okay, you can't argue with it a lot. Just a single. And now if I run it works pretty good. Now if at all you run it with a container in it, iterables. So if at all I make this a container, you'll be like, oh, that's very clever, you might get the answer. But no, you see this append still takes it as a single argument. That whole container is a single argument, not like multiple values. You run it, you can see that the whole container itself has been stored as a single value at the end of the list, and it's pretty good, right? Now there comes a very similar one just like append. It is called as extend, and extend also takes a single argument. So I'll just show you how extend is. Here you have the same container and a dot extend. Let's extend it. That's what extend does actually. So 2 9 5 7. Okay, now you see the main difference between append and extend. I'll run it. You can see that the values inside this container has been removed one by one and put it at the end of the list. That is what extend is doing, extending the list full with that iterables. It takes the argument, single argument, but it takes the iterable of it. If you see the docstring, you can see it takes the iterables. And here append, it takes the object. Object is nothing but integer, float, boolean, whatever. Okay, then yeah, I think these both are clear. So make sure you don't get confused with this, and don't also do this part, like You don't give just 2 here and say I gave a single argument. No, extent expects you to have a iterable. When I say iterable, it should be a container of a tuple or a list. Even if tuple is also fine, you can give a little tuple here. Let's say 2 comma 4 comma 5 comma say whatever. Yeah, see, it works pretty fine. Let's check out another containers built-in method. Let's see. We'll see. Okay, we have reverse built-in method. Don't get confused with the sorts attribute reverse. That reverse was for sort functions built-in attribute, nothing much. This reverse is a built-in method that you will use where you can literally reverse it, and this also returns none, so you have to print your actual original container 531. It was 135 or 531, simple as that. Let's try one more function built-in method. So reverse is done, extend is done, remove. Okay, remove is very simple, it just removes the value, but notice that it raises value error if the value is not present, and it takes a single argument which is nothing but the value itself which you want to remove. And also notice that it is similar to how we found the index dot index one for a tuple. You see it only removes the first occurrences, so I'll remove 3, the middle value is gone. But let's say I have 3 here, that guy is still there. See, that's how remove works, it removes the first occurrence. And what if this I'm removing some value which is not existing, value error, you can expect it. That's how dot remove works. And let's try a different method. So we have insert. Okay, insert, you can see the doc string, and you can see it takes 2 arguments, that is nothing but index and the object. So insert literally tells that whatever value that you want to object literally that you want to insert, and you can give the index position where you want it, and the index position you give, it inserts it before it, not after it. Okay, so if you say at the index position 2, it is going to put the value at the index position 1. So I'll show you how it works. So insert, first value is the index value and second is the object. Okay, so at index position 2 put 100. Okay, and I'll run it. This also returns none, that means I have to print the original container. And yeah, at the index position 2 you can see 100 has been done. I mean 0, 1, 2 was actually 5. So what you do, you push the 5, so 5 goes to the right little bit, like you just go that side, this is my spot, that's it, and 100 has taken that spot. Now what you have is a equals, okay, I just can do control V, fine. Let's see the next built-in method. Clear is very simple. Clear is like you just clear it, and yeah, you have an empty list right there, you just clear whatever values you had. This clear looks like very useless because you have 3 values here, but imagine you have a million values. Now it's very useful, right? You cannot manually go backspace and keep it. That's how it is. So the examples that I'm showing you here are looking very simple, but they are very powerful, so don't forget that part. And let's take a dot count and index. You have already seen in tuple, it's same for list 2, don't have to worry about that. Then you have pop. Pop is pop the values, and if at all you don't give any values in this one, it returns the value that you are popping. And if you want to check, it has popped the value, the last value. So if at all you don't give any value inside pop as an argument, then it pops the last value of it, and it just returns it. Now if at all you want to pop a particular value you desire, just give the index position of it. So let's say at the index position 1 I have to pop, so it is nothing but 3 is popped, and you get it 1 comma 5 as the original one. So I have to see which value is popped. I can store it in a variable too. You can say print b, print, I'll say, oh my bad, I didn't print anything, so I'll say this value is popped, and I'll say, what is that, b. See, this value is popped, maybe double colon is looking good. Yeah, simple as that. Now the next one what you're gonna see is called copy. This copy function is, method is very important. The reason is, you saw many of these built-in methods actually does the changes in the original list. And let's say you have come across a situation where you don't want your original list to change at all, you want it to be intact, you just want to experiment with it but don't want to change it. But how can you experiment with a list that you don't want to change? Take a copy of it, right? That's how copy works. So I'll take a copy of this particular container and I'll put it in a new variable b. Now this should work pretty fine. If I change anything in b of 0, I'll access first. So b of 0 is nothing but 1, same as the original container a of 0 is nothing but 1, 2. Now if I change the value here 10, and if I see in b is changed. Yeah, that should happen, right? It's just a copy of it. Did it change in a? You have to check. Yeah, a is perfectly safe and sound. But now what happens if at all you have a nested container, I mean nested list, for example. Let's say you have 3, 4 here, and then you have 5. Now what I'll do, at index position 0, not 0, let's keep it 1. 1 is nothing but this particular container, nested list. And inside that nested list, I want to actually change the value of 3 to 10. Okay. Now if I print this b, yeah, pretty good. That's pretty normal answer that you got. The value of 3 has been changed to 10 in the copy of it. Copy. You are taking a copy, right? Now let me check a. It has been changed even in a too. You have seen that in a it is actually 3, but still it is changed. So what you do is you take deep copy of it. Whatever I showed you here, this is known as shallow copy. Shallow copy, let me write it down, shallow copy. So when you're taking shallow copy, this one is not completely independent from the original list what you have. So in order to keep it completely independent, you import a deep copy, which is actually in a built-in library called copy. So you say from copy import deep copy. You don't have to give a parenthesis. And now I'll take the same list, Control C, and I'll say Control V. And here I'll say a of, or maybe I'll say deep copy. I'm taking deep copy of a and I'm assigning it to the variable b. Okay. And now I have a deep copy. This one is very independent from the original. So how do I know that? Let's do the same experiment. Let's say b of 1 of 0. So make sure it's like this, okay? And when I say 1 of 0 is 10, it has changed in b. Fine. Now the question is, did it also affect a? Let me see. A is intact, safe and sound, like how it was before. Now this is how deep copy helps you to keep your list completely independent from your original. So yeah, make sure whenever you are using shallow copy, you don't have a nested list and you don't want it to get manipulated much. So here, as you understand this list and tuple, there's a question that which one is better, right? So if you look closely, you can see that list is actually slower compared to tuples, because tuples, when you declare it once, it is done. You're not able to manipulate the data. Everything is fixed in a tuple because it is immutable. But when it comes to list, your data can vary inside a list. You can maybe change the data types, you can add something, you can remove something. So that literally makes list slower in execution time, whereas tuples are pretty much faster. But there is also, you cannot say that list is not better, like list is bad compared to tuples. You cannot tell that term. You can't come to a conclusion. It really depends on your use cases, how you are using these containers, because each of these built-in containers have their own specialities. So whenever you are trying to get fixed outputs like coordinates, you want to return some coordinates or a return statement from a functions, there you can use tuples. Or maybe whenever you want something where the data can change at any moment, where you want that mutability, that is where you can use list. Like when you want input from a user, the user can give any input he wants. That is where you can use list to store those values which can be changed. And this shows that list can be very flexible unlike tuples, and in list you have something called as list comprehension, which actually makes list faster, but not in the execution part, just in how you can literally build the syntax for list. Let's say you want to store some values in a list, there is list comprehension that helps you to store it much faster from the traditional way of how you store it. And before I show you how list comprehensions work, you have to be thorough with how for loops, looping statements, and also the if conditions in Python. So if you are well and good with that, only then you can watch this one. If not, you can skip this part. It's totally fine for the beginners. The people who know this fundamentals of looping statements and if conditions can watch this. So here I'm creating an empty list, and now I've given a question that fill this list with 100 values. Okay, what I'll do is normally I'll take a for loop, so I'll say for I in range, I can keep the range as 100, so it will start from 0 all the way to 99. Let's keep it 1 to 100, right? So 1 comma 101, because stop is exclusive even in this range too. And I'll say a dot append, what do you see, I. And now if I see a, I'm getting all these 100 values inside this particular list. I'll print it so it will come horizontally. Yeah, you can see all these values inside the particular container that I created. I used a for loop and it was very simple, right? Now this one took like 3 lines, around 3 lines. What if I say I can do this in a single line? Now same thing, I'll say a equals, I'll keep a empty list, and inside that list itself I'll say for I in range from 1 up to 101, nothing but up to 100, iterate through all these values. And also whatever I'm iterating, I want to keep it in my list, right? So what I'll say, whatever value that I want to keep it comes at the leftmost side of the list. So I should be here, space for I in range 1 comma 100. So now if I print a, I'll just print, because when you're using Jupyter notebook, you just make sure you print it, or else it will come in a vertical output. Yeah, so when I print it, you can see that all these values are inside it. Pretty straightforward, right? But you can see that the readability has been reduced. This is one of the drawbacks you can say that you can have. Make sure that whenever you are writing a code for a beginner, you normally write code and you use this list comprehension, make sure you are not using it too much while you are in a beginning stage or you are working with some beginners of the code. If you are working with people who actually know this, then it's well and good, because the readability can be reduced a lot when you are writing things like this. And now you have seen that how easily I can write all these, put all these values inside it without using append function, the built-in append method. What if I say I have to use if condition? So normally when you use if condition, I want to keep only the even numbers or odd numbers. So I'll say if I equals 0, so if the remainder is 0, only then append I. Now what happens in this, you are getting only the even numbers. You can see only even numbers. Same thing you can do in list comprehension too. You say if, so if condition comes at the right side, if, and notice that if I %2 equals 0. See, whatever you wrote here, same syntax, but in list comprehension it looks like this. Whatever value you want to store at the left side, and the for loop in the center, and the if condition at the right side. But also make sure you have only if. What if you needed else condition? If and else can be like a dot append odd. What if it was something like this? Just an example, okay? And I'm running, you are getting it like this. Fine. Notice that when you are using list comprehension, if at all you give else here and say odd, what do you say? ODD, odd. You can see already it is throwing an error, invalid syntax. So what you do whenever you have if and else, when you have both these conditions, only then you take this, put it at the center. Now it's fine, it works, and make sure you have 0. Oh yeah, before I think, wait, this part, it's not because of the 0. If I run this, else is still an alt. This whole syntax is wrong, it says. So make sure that this whole thing, whenever you have an else condition, you have it over here. Okay, so it's like I is the actual value that you're going to store. The if condition, if at all it's only if condition, it goes at the rightmost end, but you have if and else, so it is at the middle part. So if condition, else condition, then you have the for loop. So else odd, and now you run this, same thing, it works pretty fine. This is nothing but your list comprehensions, which will actually make your declaration of a list to store values or data types very faster compared to before. I'll show you one more thing in tuples. Tuples doesn't have something called as tuple comprehension, but it has something which is very similar to it, like a generator expression that you can use to actually make it more faster, I believe. So let's see that. So generator expression can be used for tuples in order to be like almost similar to list comprehension, because tuple doesn't have something called as tuple comprehension. You have a, and let's say this, what you say, expression, generator expression, you represent it in parenthesis. It doesn't mean it has to be a tuple. Okay, so I'll say for I in range 100, and here I have to make sure that this I is there. Now if I print a, this gives me just an object. Now what should I do? It is stored in some memory and it's like a generator expression there, right there. You have generated some values, but what to do with this value? Should it be in a container? Should it be in a, what do you say, a tuple, a list? You have to declare that. This generator expression can work on a tuple or a list. It doesn't matter unless you decide. So here I can give the built-in function method tuple. I'll say this, let it be a tuple, and if I run this, that is a tuple now. So I'll print this, and you can see, one second, print a, and yeah, this here is a tuple that you have created. If I want to see the type of a, it belongs to class tuple. Now the same generator expression can be changed as a list too. Just change this into a list, and you can see that it belongs to class list with whatever values you want. And maybe if at all I try to, if I say I person 2 equals 0, see, it works almost similar to how list comprehensions work, but this is called as generator expression, which is not same as list comprehension. This one helps tuple to be faster in what you say, generating the values into it, like storing those values. But in the end, whatever you use between this list comprehension or you say generator expression, tuple is always going to be faster than list. I will show you an example with the code. So here I am going to declare a generator expression for tuple, and I'm going to store the values in a tuple using generator expression, and I'm going to store the values in list using list comprehension, and we are going to compare the time here. How much time does tuple take and how much time does list take? Is tuple faster than list or vice versa? So here what I'll do is, before we have to if we have to compare time, we have to import the time library. Then what I'll do is I will create something called as numbers. So the range I'm gonna give 10,000. Let's keep it 1 lakh. Okay, now 1 lakh numbers, and then here first thing I'm going to declare is the start time. So start equals time dot time. So you are taking the time now time, and then you will say a tuple. You are creating a tuple which is going to use generator expression to store the values. So I'll say tuple, you know this part, I, for I in, don't need range, you need numbers, in numbers. Okay, now you end it, so you want to see how much time did it take and to create this one. So time dot time, and you have your print statement. In print statement, what you do is you say time, you give the notification time taken for tuple using what you say generator expression GE. I'll give it short form GE, and then I'll say end minus start. Okay, so literally we have this. Now in order to check for list, you can copy the same code because it's very similar. You just have to change this part where you have a tuple here, just make it into a list comprehension. What you do, you give square brackets here and you say this is a list, and time taken for list by using what? List comprehension. So this should be LC, I'll say. Now notice that I hope you understand this code. We are importing time. We are giving a range of 1 lakh values to a variable called numbers, and that numbers are being iterated in the for loop in generator expression for tuple, and you are storing those values. You are storing 1 lakh numbers in a tuple using generator expression here, and that start and end, the starting and ending of this particular code for tuple generation, you are just taking the time. You want to calculate the time. Here also same thing. Start, you have the starting time, then you store the values in the list, and end time, you are taking the time where it ended. Now I want to see the difference between these two, which one is faster. So I'll run this code, and you can see that this tuple using generator expression is actually faster. So you can see that 0.0080, it's not faster. Here the actual one which is faster is list. You can see that it took only 0.004. 0.008 is slower. Your tuple has become slower, even though tuple is said to be faster than list. When it comes to list comprehension, list is faster in storing variables or storing values inside it. Got my point? It is slower in the execution part. Let's say you have to find random numbers in this particular list. It will be much faster to find those numbers in tuples because it is very memory efficient, but when it comes to list, it is slower. So you got my point? I'll just try to, okay, I'll show an example where you import random, and what you do is you can see that I've declared numbers here. I'll just say take a tuple where it has a range of 1000 values, and this should be tuple of range of 1000, and same way I'll create a list. Okay, I'm creating a list. So this should be list of range 10,000, and then same, we'll check the time for those, how much it takes while you're accessing values. Okay, so I'll say for in tuple, okay, and then you say a tuple of random values, right? So what you give here, random dot rand int of 0 to 1 2 3 4 values. Okay, same way, Control Z, see, now this same thing we'll do it for a list. Okay, for list, and this can be around, let's keep it for in 10,000, I think range, or maybe this is only fine, yeah, and we'll say time taken for a list using LC. There's no LC here. Time taken for a tuple. So accessing random values, okay? And if you run this, go as B. What's B, bro? Here, tuple random dot random. B. Oh, okay. This. Yeah. Now you see that, sorry for the syntax error, I didn't notice that I have given a hyphen there. But you see that time taken for a tuple is 0.05 and time taken for a list is 0.06. You can see the difference here. Tuple is actually faster when it comes to accessing values or some execution parts. So here, this is the important thing. Whenever you are using list comprehension, you are only faster in storing those values in that particular list. You are not faster in the execution part. So overall, when it comes to an all-rounder, you can say tuple is still the fastest, but when it comes to storing values, then it is list whenever you are using list comprehension. So that's all for this video. I hope you found this helpful and this video gave you a clear understanding of how list and tuples are working, and they are very quite similar yet quite different. And in the next video, I'll be going in depth on how set and dictionaries work from scratch to advanced. So stay tuned and see you all in the next one. Thank you.